Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about systems of equations and applications. The first problem we have is it says a candle supply store sells votive wax for 90 cents a pound and low shrink wax for $1.04 a pound. How many pounds of the low shrink wax and the votive wax should be mixed together to obtain an 18.6 pound blend that sells for 98 cents a pound? So if you remember, we need to create some variables here, and the variables are representing what we don't know. And what we don't know are the number of pounds of low shrink wax used in the mix, so that's L, and then the number of pounds of votive wax used in the mix, and that's V. And then remember, we need to write two equations, and the two equations are going to be total cost and total weight. So here the two equations should be V plus L equals 18.6, and then 1.04 L plus 0.9 V equals 18.22. And this 18.228, that came from the fact that we took 18.6 pounds of the mixture times what we were going to be charging per pound for it. So when you multiply those two together, you get the 18.288. Now, once we write these two equations, the first task is to solve this using substitution. And depending on which variable you want to substitute for, I'm going to go ahead and use this V plus L equation. I'm going to say that V equals 18.6 minus L. Now, once I find that V is equal to 18.6 L, I'm going to use that to substitute in for this equation here. And that's what I wrote down here in the green right underneath there, is how that would substitute in for V. Then I went ahead and solved it first using the distributive property. So here and here give you these two terms. And then I combined the like terms here and here to get that term. And then I subtracted the 16.74 over from both sides, and that's where I got this equation. And then I divided both sides by 0.14. And that's how I got L is equal to 10.62. And this is an approximate value because this is an unending decimal, but approximately 10.62 pounds of the low shrink wax was used. Now we can use that L value to plug into our V equation up here at the top. So we would say, we would plug into this equation for L and then solve for V. So we're using L here to plug into here, which gets us this equation here, and then we're going to find that V is going to be equal to 7.98 pounds. And again, that's an approximation because L was an approximation here. So that's how you would solve using the substitution if you solve for V in this equation in the beginning. Now let's look at that same process with solving for L. So if we decide to take this equation here and solve for L, we would get this equation down here. And then we would use that to substitute in for L in this equation. And that's what I've written down here in the green. So we would take 1.04 and substitute this for the green. And then I go through and I show you how to solve that. So here you got the distributive property. And you get these two terms with the distributive property. Then I went ahead and combined these two like terms and got this new term here. Then I went ahead and subtracted this from both sides of the equation. And then on the last step, I divided by negative 0.14 on both sides. And that gave me that V was 7.9 pounds exactly. So now we're going to use that to substitute into our other equation to solve for L. So we would take V here, and we're going to substitute that in for this equation. So here, the work to do that would be substituting V in here for this equation, and then you get 7.9 or 18.6 minus 7.9, and so you find that L is exactly 10.7 pounds. So that's how you'd use substitution, finding the L and the V values in this equation. Now let's look at the graphing portion of this. So to do the graphing portion, we need to get one of the variables by itself in each of the equations that we wrote, so the total weight and the total cost equation. And usually you want to start with the total weight equation. That's the easiest one. So let's go ahead and start by getting V by itself here. So we would say V here equals 18.6 minus L. And then we would want to do a similar thing in this equation here. And so to get V by itself, we're going to subtract 1.04L from both sides. And then we're left with 0.9V equals 18.228 minus 1.04L. And then we're going to divide everything by 0.9. And these are going to come out to be kind of crazy decimals, but we can kind of chop them off after a couple places. So once we solve for V in this equation, you get that V equals 20.25 minus 1.15L. So we have our two equations now set equal to V. And we want to go ahead and use those to create a graph. And the V here then is going to be our vertical axis. We're going to call V our vertical axis, and then we're going to call L our horizontal axis. And on this red equation, we know that our starting point is going to be 18.6. So we can kind of approximate this. We can go that each of these boxes is 2. So you said 2, 4, 6, 8, 10, 12, 14, 16, 18. This would be 20 up here. So 18.6 is going to approximately be right here. And then we have a slope of -1 in this equation. So we're going to be going down 1 for every box on the horizontal axis. So down here on the bottom, the L axis is the horizontal axis. So if this is 18.6, then going down, we would have to go to here to get us to 1. So, and again, we're going to just keep going downward in a constant pattern. And then we connect the dots. And that would be our equation here. That's what this would represent. And then we can do the same kind of thing with the green equation. Our starting point in this one is going to be 20.25. So we got, this was 18 here, so this is 20. So 20.25 is going to be about right here. And then our slope is a little steeper on this one. On that one, it's going to be -1.15, so we're going to be going down a little steeper. And I'm sorry there, we made a mistake on our graph. And so let's go back. We made the V-axis, the vertical axis, and that was this equation here. And we have a starting point of that equation of 18.6, which we can say is approximately right here. Okay? And then if we want to go down 1, if we have a slope of -1 here, we want to go with the horizontal axis the same amount that we did with the vertical axis. So each of these boxes down here is 2. So you got 4, 6, this is 8, 10, 12, this is 14, and so on and so forth. So then we can go down a constant rate here using the same scale on both axes. So we're just going to keep going down a constant rate here on both axes. So this new blue line should represent the red equation up at the top. And then now we can start with the green line at 20.25. So that's going to be approximately here. And here we have a little bit steeper slope in this one. We have a -1.15 slope. And so we want to find out where these two graphs are going to intersect. So the starting point again, 20.25 on the V-axis. And then we know from our substitution solving with V and L, we know that L is going to have to be 10.7. And so that's going to be approximately here on the graph. And then we know that V has to be about 8. So that's going to be about right here on the graph. So our point of intersection should be here with these two lines. And so you need to use that information to help you to create the line. And we know then we can create a line that kind of represents that a little bit nicer. And these are tough because they're not precise. They're just estimations, but they're good tools to just kind of get a feel for how the graphing is supposed to work in a real life sense. So that would be how you would solve and graph the V equations. Now let's look at the L equations. So if we go back to our original two equations, the total weight and the total cost, if we were to solve this equation here for L, we would say L equals 18.6 minus V. And then up here in this equation, if we were to say solve for L, we would subtract the 0.9 V from both sides. And then we would be left with 1.04 L equals 18.228 minus 0.9 V. And then we divide everything by 1.04, divide by 1.04, and then we'd have that L equals 17.52 minus 0.86 V. So those are the two equations we're going to use in our graph now. So let's go to that. And here, now the L axis is going to be the vertical axis here. And then our V-axis is going to be horizontal. And again, we have a starting point of 18.6 in this equation. And we're going to make, again, our scale going to be 2. We're going to have 2 for every box that we're going upward. So this would be 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay, so we're going to be starting approximately here with that red equation. And then going down, and again, the horizontal axis, we're also going by 2s on the horizontal axis. And then we're going to use that same slope going down, down, down here to create our red equation line. And then our starting point for 17.52 on this equation, we're going to actually have a starting point of approximately right here. And then again, this equation, we know where the intersection of the two graphs should be. It should be approximately at the point where V is about 8, so 2, 4, 6, 8. So we're going to be somewhere around here intersecting. And then we also know that L had to be equal to about 10.7. So 10.7 is going to be somewhere around here. So that's our point of intersection. That's what we want to shoot for when we're creating our line for the green. And so let's go ahead and create that dot right there for our point of intersection. And then just create your line to go through that dot here. And if you have trouble use a straight edge. The straight edge, like a ruler or something, will be very helpful for you. And again, these graphs don't have to be perfect. They're just estimates, rough estimates, and to get an idea of what this visually looks like. So that concludes our lesson, and hopefully it's been helpful for you. Thank you.